Example 3. This example 3 is on substitution. You know, we are considering algebraic fraction and substitution. In substitution at times, you do the fraction, you do the substitution. But the first two examples only dealt with algebraic simplification, algebraic fraction. Whereas the third example, the fourth one, and the fifth one we are going to consider, they combine the two together. You actually see the element of substitution there. See, find the value of this expression when x is equal to 1. Don't be in a hurry and say, you have been given the value of x. My friend, this thing is very simple. You now slot it into it. You now have 1 over 1 minus 1 minus 2 over 1 square minus 1. You realize here that you will have 1 over 0 minus 2 over 0. Because 1 square is 1. 1 minus 1 is still 0. Now say, how do we go about it? Let's forget the damn part. Let's say 1 minus 2 and your answer is minus 1. It's wrong. If it is in theory, we won't give you. And if it is in objective, it may even be wrong. And coincidentally, your answer may be the correct answer, but that is not the way, and it may not be the correct answer. How do we do it? Simplify it first. Simplify the fractions first before you make your substitution. So how do you simplify? X over x minus 1 minus 2 over x squared minus 1. The LCM is x squared minus 1, don't forget. X minus 1 in x squared minus 1, that gives us x plus 1. Remember, x squared minus 1 is the same thing as x minus 1 into x plus 1. Don't forget in the difference of two squares. So x minus 1 in x squared minus 1 gives us x plus 1. X plus 1 times x, we have x into x plus 1 minus x squared minus 1 in x squared minus 1, that is 1. 1 times 2, that gives us 2. So we have x times x, that's x squared. X times plus 1, that is x, minus 2 all over x squared minus 1. Looking at this, the numerator here has formed quadratic, 3-term quadratic expression for you, which you have been taught. Now that this one enter into 3-term quadratic expression, then you do the normal thing. Multiply the first and last term together. So you have minus 2x squared. And the middle term, you underline for the process. How do we now go about that? We have 2 into 1. How can we manipulate 2 and 1 to get positive 1? It is possible. 2 and 1 to get positive 1. We say 2 minus 1. Now, can 2 times minus 1 give us minus 2, which is the coefficient of this? Yes, it gives us. That means these two factors are variable. So you have x squared. In place of the middle term here, you write minus x plus 2x. I interchange them. You can write anyone first. Don't forget. So minus 2. All over, don't leave this denominator aside. So this one will become x minus 1 into x plus 1. Don't forget. Up here, it will be x into x minus 1 plus 2 is common to this into x minus 1 all over x minus 1 into x plus 1. Let me use this side to complete it. We continue it here. Factorizing the numerator perfectly, you have x minus 1 into x minus 1. Factorizing the numerator, you have x minus 1 into x plus 2. Now all over the denominator, x minus 1 into x plus 1. Looking at the expression, you can see that there is a factor in the numerator that can easily crush a factor at the denominator. This crosses this. So we have x plus 2 over x plus 1. This is the appropriate place where you can now substitute the value of x given to you at the beginning. So you can now say, now, since x is equal to 1, therefore, this is 1 plus 2 over 1 plus 1. Answer is 3 over 2 or 1.5. But someone who make direct substitution would have gotten minus 1 or 0 as its own answer, which is wrong. So take note of that. Example 4. This kind of question is a standard question that comes out in virtually every external examination. Please take note of it. If x is equal to y plus 3 over 2y minus 1, express 2x plus 1 over 3x plus 1 in terms of y. When you see a question like this, please, it's simple. Don't be scared. See how to do it. The question, the expression you are given to express, you write it down first, which is 2x plus 1 over 3x plus 1. You have to express it in terms of y. You now write 2 into, wherever you see x, you put in place of that x, you substitute into the position of that x the value that x assumes. According to this, x is equal to y plus 3 over 2y minus 1. So put it there. Y plus 3 over 2y minus 1. That is x. You put in the place of that x plus 1 all over. The same thing you do here. 3 into, what is x? The same thing. Y plus 3 over 2y minus 1. Now plus 1. This is real substitution. You are really substituting. So open this bracket. When you are opening bracket, when you are using something to open the bracket in which we have fraction, whatever you are using to open the bracket will multiply the numerator only. It will not multiply the denominator. If it is a whole number that is not a fraction, and you want to use to open the bracket of a fraction, that whole number, that entity will multiply only the numerator of the fraction. So we have 2 times this. It will be 2 into y plus 3 over 2y. 2 times minus 1 minus 2. So you write the plus 1 to follow immediately. This line of division, use it, bracket this together first, and use the line of division as division sign to make it easier. Instead of writing this line of division and building story building, no, use it like this. And open another one in which you will put this. 3 times this, that will be 3 into y plus 3 over 2y. 3 times minus 1 minus 3 plus 1, put it. Put the larger bracket. Let's simplify this. So you have opened this bracket to, in opening this bracket, before you open the bracket, you can see that these 2 can cut these 2 to have y plus 3 over y minus 1 divided by, open this bracket, open this one, you have 3y plus 9. We cannot use 3 and 2 to cut each other because they are not, you understand? So over 2y minus 2. So find the LCM in this bracket. The LCM is y. y in y, 1. 1 times y plus 3 is y plus 3 minus 1. There is a denominator of 1 under this 1, invisible. That 1 in y gives us y. Y times minus 1, we have minus y. Divided by, now, the LCM of this also will be 2y. 2y in 2y, 1. 1 times 3y plus 9, it will be 3y plus 9 minus, there is a denominator of 1 under these 2, which is invisible. That 1 in 2y gives us 2y. 2y times minus 2 gives us minus 4y. I continue from here. So, y plus 3 minus y over y gives us 3 over y. Because y minus y is 0. Plus 3 over y. Divided by 3y minus 4y, that's minus y, plus 9. You can write it as 9 minus y over 2y. Is it clear? Anytime you are operating with division, 3 over y will turn to the division will turn to multiplication, and the divisor, which is 9 minus y over 2y, will turn upside down. That is reciprocal. The inverse of division is multiplication. So while this division sign turns to multiplication, the divisor, this divisor also turns upside down, 2y over 9 minus y. So multiplying the two together, 3 times 2y gives us 6y. Then y times 9 minus y gives us y into 9 minus y. You can see that this y and this y can take care of each other. So you have 6 divided by 9 minus y as our final answer. So that is how to write something like this in time of y. That is proper substitution. We are going to the last example for the day under this subheading, which is example 5. If p equals x plus 1 over x minus 1, express p plus 1 over p minus 1 in terms of x. What you are to express, bring it out. P plus 1 over p minus 1. Now, you want to express it in terms of x. How? Wherever you see p, what p is known to be, what p has been given to be, the value that p assumes in the equation given to us, put it there. In the equation, p equals x plus 1 over x minus 1. So wherever you see p also here, you write x plus 1 over x minus 1. That is p alone. You now say plus 1 all over. Again, what is p? X plus 1 over x minus 1 minus 1. You have written this as this in terms of x. It is only x we see there. You don't see p again. That is it. Now, what is the LCM of what we have up here? What is the LCM? The LCM is x minus 1. X minus 1 in x minus 1 is 1. 1 times x plus 1, it is 1 into x plus 1. Now, this figure 1 has the denominator of 1 as well. So that 1 in x minus 1 gives us x minus 1. So that x minus 1 times the 1 of the numerator, it gives us plus 1 into x minus 1. That is the numerator part of this fraction. This division sign, instead of writing it down here and continuing with it, I want to write it beside here as division sign. It's a line of division, and it could be written as this symbol. So I write it as that symbol, I open the bracket, I find the LCM of this also, which is x minus 1. X minus 1 in x minus 1, that is 1. 1 times x plus 1, that gives us 1 into x plus 1. Minus. This negative 1 has a denominator of 1, which is invisible. That 1 in x minus 1, it gives us x minus 1. X minus 1 times this minus 1, we now have the minus 1 into x minus 1. So, we can now continue like this. Opening this bracket, 1 times x, that's x. 1 times plus 1, that's plus 1. Plus 1 times x, plus x. Plus 1 times minus 1, minus 1. All over x minus 1. Divided by 1 times x, x. 1 times 1, 1. Minus 1 times x, minus x. Minus 1 times minus 1, plus 1. All over x minus 1. X plus x gives us 2x. Plus 1 minus 1, 0. All over x minus 1. Divided by x minus x, 0. Plus 1 plus 1. That is plus 2. All over x minus 1. I continue on this side. 2x over x minus 1. The division sign here, we turn to multiplication. And the divisor also, we turn upside down. That is x minus 1 over 2. So, looking at this critically, you can see that x minus 1 and x minus 1 can cross each other conveniently. So you have 2x over 2. From there, 2x divided by 2 is also what? X. So the final answer is x. So far so good. We have been able to do this under algebraic fraction and substitution. I want to believe you understand the nitty-gritty of this. I cannot assume you understand until I give you some assignments and you feed me back in the next class with good answer. Let me give you some assignments to try your hands on. I cannot leave you without assignments. So these are the assignments, the questions of the assignment I have for you. Try your hands on them and see how you fare with them. Thank you.